antenna real estate is very important to us, and they try to minimize that and put those more into 2 or 3 antennas versus 5 or 6 antennas for sure.
And on the band 41, obviously I think a lot of people have experience with Sprint and then doing an 8-port plus obviously 12 channel. Are you at that, or are you starting off more on the 4x4 side? And you said you had to put a separate antenna. Is there some plan at some point to obviously include that into a more integrated antenna, or do you want to leave that as a separate panel?
Well, we would like to integrate it. We would like to reduce the number of antennas in antenna count just for real estate purposes. But we have deployed 8x8 MIMO in our band 41. It came out of the box that way. Most of our CPE devices are 2x2, but at least with 8x8 they get it. The opportunity is there for them to take advantage of that a little bit better. The pairs are better. And so we're looking for CPE devices or from our CPE vendor to at least get the 4x4. All of those, I was interested to see the potential indoor installation of a millimeter wave CPE device. I don't think that's very practical at all, even at 100 to 200 meters. I think that's wishful thinking. We've seen in our band 41 deployments. We try to keep our band 41 deployments less than 3 miles with an outdoor antenna. We're getting decent SNRs or 10 or better, and so the throughput is pretty good with using 2x2 MIMO. Fortunately, you also get better MIMO percentages with outdoor antennas versus indoor units. You have more control over the direction it's facing and how it's mounted, as opposed to the customer hiding an indoor CPE unit under a bed or behind a TV or something like that. So the MIMO possibilities are very good there. So, but yes, decrease that antenna real estate for sure.
David, Kevin talked earlier about the different topologies for doing master MIMO from the traditional analogs and then the hybrid and the digital in terms of some of the complexities on the technology side. Maybe you can again walk us through a little bit about where are some of the cost trade-offs when you look at making that antenna and adding all of those extra electronics on the phase shifter side, all the way to all of the DACs and everything else that we might need to cram into this unit. And I think today the market seems to be moving towards, I just want to digitize every element that's out there and just and go forward with that. But I think at some point we see the performance benefits of some of these solutions out there relative to the cost of digitizing 128 or 256 channels as we get to millimeter wave, or it is a potential hybrid approach might be better for everyone in the industry.
Oh, sure. Let's go from the most complicated to the least complicated. The most complicated, let's say we're at 128 elements like what Earl talked about. That means you essentially have to have 128 radios in it. I mean, each radio is simplified as compared to a radio that you would put on a tower today, because we are not doing all the baseband processing and sending out to the network from each radio. We're going to somehow take that RF signal and bring it down to baseband and send all the baseband somewhere else to be further processed. So in terms of cost, if you think of a radio today might cost you a few $1,000s for a 4x4 MIMO radio. Now if I have, because each antenna is 2 ports called a 2x2 MIMO, that means you're 128 times 1,000 if you were to think about it that way. Although it's not quite that, like I said, because all the capabilities aren't like that, but the cost could be quite dramatic. A hybrid system, going back one, is where you start out with, at the antenna, you start out with some sort of analog beamforming, let it be a bootlace or Rockman lens, or just a passive network combiner. So you're reducing the number of ports that you're putting a radio on. So you may start out with 128 elements, but let's say we combine each 16 element column. That means we have 8 columns, which means you would only need 16 columns 16 radios because you have 2 polarizations on each. So that's a much simpler, more in terms of the electronics and lower cost. Now you still can do things with that hybrid network because you are allowed to change phasing and change other things within that hybrid network. Or you may have like a lens that you're switching between different ports to connect up all those. So you are talking about reducing the cost of the electronics. You don't get the arbitrary beamforming that you do from the more complicated digital beamforming network. However, you can point to many different angles. So the hybrid combination is more cost effective to be able to do that. The traditional analog, you're combining, all your elements into 1 or 2 ports. You're only having 1 radio at each port, so the number of radios may reduce to 1 radio or 2 radios. So cost-wise, you can do that, but the number of features, the number of different beams, the architecture won't allow you to do much more complicated beamforming like the hybrid and like the digital. So from a cost perspective, you're going from the traditional low cost, you're moving up the ladder for the hybrid to the full digital. But you're also adding more and more features. The question will be, as we move from 4G to 5G, where do we need to stop? So what's acceptable to start? I mean, someday, just like Kevin pointed out, at 2028, we'll probably have a full digital network. But today, at 2017, or 2019, 2020, when we start fielding some of these, that full digital network won't be necessary for hundreds or thousands of elements yet. Eventually, for massive MIMO, I think we'll see all this. But in the near term, I don't think that is a cost-effective solution or a the difficulty in terms of the hundreds and hundreds of components that you're going to find together will be quite dramatic now. I think we need to make our way in terms of steps to get